As this course is called Functions, we're going to take today in the first lesson to define what a function is, and more importantly, what it isn't. Okay. In math, we often deal with relationships between values, between numbers and pictures and other important information. Everything that has a relationship, there's some sort of connection between two things, can be considered a relationship. Okay. There's a relation between your two variables, whatever they happen to be. A smaller group of those relations are actually called functions. The definition of the function means that no two different ordered pairs can have the same x value. The reason that exists is I want to be able to use my function as sort of a machine. When I put something into it, I know what's going to come out of it, and it's never going to change. So for example, this is a function because I have 4 different x values. The red one is a relationship because sometimes when we put x as 3 in, we get a y value of 5. Other times we put x as 3 in, we get a y value of 1. So this is considered a relationship because yes, there's some connection between these numbers, but I can't put in different x's, the same x and get different y's. 1x, 1y, that's all we can have. Okay, so we're going to look at some ways of recognizing functions today. A couple of different ways. The first thing is a mapping diagram. A mapping diagram consists of 2 sets and a rule for assigning the values in one to the values in the other. And generally, in a mapping diagram, this would be our x values, and these would be our y values. And the first set is considered a function because each x value only points at one thing. And the rule here is y is equal to x squared. When x is -2, it always comes out to 4. When it's -1, it always comes out to 1. When it's +1, it also comes out to 1. It's okay for different values to point towards the same value like we did with the 1s, but a single x can't come out to 2 different y's, as opposed to the second one, or if we look at the number 1, sometimes it comes out to a 2, and other times it comes out to a 4. So as soon as you see an x pointing at more than one value in the y diagram, you know you have a non-function. As we said, we're going to call those relations. So diagrams are pretty easy. Does it point more than one direction? A more important tool for us is a graphic decision maker. And what we use in a graphic decision is we use something called the vertical line test. And here, we're going to take our function or our relation, and we're going to say to ourselves, if I were to draw a vertical line through this graph, and no matter where I draw it, does my line pass the graph only once? If it does, that means it's a function. If it doesn't, it's not a function. That sounds kind of complicated, so we're going to look at some examples here. So, if I look at the first graph, I'm going to draw a vertical line right there. Now, I don't have to keep the vertical line there. This vertical line can move. It has to be able to be drawn anywhere. So if I draw my vertical line anywhere, how many times do I actually pass through the graph, the green line? If I think about it, I pass through it once right there. If I remove it, I still only pass once right there. If I were to move it, I only pass once through there. So no matter where I draw my graph, every single time, my line only passes through the graph once. That makes this thing a function. When I put in an x value of, let's try this one here, -2, so when x is -2, y always comes out to 1. Okay, that's a function. Let's try the next one. Take our vertical line and we draw it. Right off the bat, I'm hoping you'll notice that when I draw it right there, I get one spot in the graph and the second spot in the graph. This is a problem. This is not a function. This would be a relation. It passes through my graph more than once. If we go back to our first idea, just to make life a little bit easier, let's pick some nice ones here. If I were to draw it right down the middle there and say, well, when x is 2, I can get a y value of I don't know, what's that, approximately 1.25. Or I could get a y value down here of negative 1.75. I can come out to different values if I plug in an x in a function. So that tells me this is a relation. But it's faster to just think of it as a vertical line test. We'll try the next ones. Okay, so this time my graph is my relationship is made of a bunch of dots. So I take my vertical line and draw it through that dot. Oh, I pass through once. Pass through once. Draw it here. Oh, I got a problem. I'm passing through twice. That dot and that dot. Now I know my line's not perfectly vertical, but if it was, it would go through both those dots. The fact it goes through 2, it's a relation. We'll try the last one. Again, keep moving my line left to right. Am I going through the graph more than once at any point? I was getting close there because that line's kind of vertical, but it's not perfectly vertical. So the fact that I only pass through it once makes this a function. Okay, so that's what our second definition. A mapping diagram, does it point more than one spot? A graph does it cross more than one time? When we figure this out, if it's a function or relation, there's some things we want to use to describe that function and or relation. And one of the big tools we use to describe them is something called domain range. And the way you can think of domain range is think of it as a picture frame. Where does that picture show up? Where does that graph show up? What values are included? When we talk about the x values, we're talking about our domain. We're talking about the y values, we're talking about our range. And you can also think of those as their independent and dependent variables. So, we're looking at a mapping diagram. It's made up of x's and y's. Mapping diagrams are nice. I want to make my domain. I can use D for domain, no colon. I use these fancy brackets. We call these ellipsis brackets. And I'm going to make a list of my x values that are actually included. So the nice thing is in a mapping diagram, you can see them all. I've got a 0, a 1, a 2, a 3, and a 4. Those are the x values included in this function. And it is a function because you only point one direction, right? If I want to do my range, I do the same thing. So we're going to use an R for range. And this time I'm going to include my y values. Which ones? 10, 20, 30, 40, and 50. As I said, mapping diagrams are nice because you can actually see each value that's been used. You can define your picture frame. The same thing can happen when you have ordered pairs. The only trick with ordered pairs is they're not actually in order. They're in order together. This x makes this y and this x makes this y. But often the pairs aren't in the right order for what we want to do for defining our picture frame.
Would Mrs. McLeod please contact the office?
So it is the same thing. Our domain, what x's do we have? So,
would Mrs. McLean please contact the office?
So our x's are all the first values. Now the trick here is we have to go from smallest to largest. So what's the smallest, the leftmost x? Well, that'd be negative 4, and then negative 1, and then 2, and 3. So I have an idea that my function or my relation, let's see if we can define what that is. Do we see the same x more than once? No. So this would be a function, right? We know that. This defines that my function only exists between negative 4 and positive 3, and not necessarily all of those values. For example, I don't have a negative 3, a negative 2, or a 0. I just have these 4 specific ones. In my range, my smallest y, my lowest y, in the vertical up and down direction would be a 1. Then I see a 2, and then I see a 5, and in fact I see 2 5s. But I'm just making a list of what points I want to include, so I don't write them out twice. I do not have to have the same number of values in my domain as I do in my range. The first one, it happened to be that. Each thing pointed once. In this one, I've got 2 different x's pointing at the same y, so I have 1 less in my range. Now, everything we've done so far has been sort of something we're kind of familiar with, an x and a y graph. Not everything has to fit into that nice category, though. We can do mathematical things with words, non-mathematical things. So in this example, we're going to look at the ages and soccer practice days of 4 students. So on certain days, they go to soccer practice. Different ages, practice different days. We want to turn this into a mathematical statement. So I want to write a list of ordered pairs and create a mapping diagram between age and soccer. So age will be my X, soccer will be my Y. So what ordered pairs do we have? Well, the first age, they're 15, and the day they practice is Tuesday. There's a pair that go together. There's some sort of relationship here. Maybe there's a function, we don't know yet. We know 16-year-olds also practice on Tuesdays. We know 15-year-olds practice on Thursdays. And we know 17-year-olds practice on Saturdays. So I've got 4 sets of data. I've got 4 ordered pairs. I want to turn this into a mapping diagram. A mapping diagram takes your X's and it puts them in order. 15, 16, 17. And then your Y's, Tuesday, Thursday, and Saturday, also in order. And then we need to point arrows between each X and the corresponding Y. So we know we have 15-year-olds on Tuesday. That's my first arrow. That's this one. We have 16-year-olds on Tuesday. My second one. I've got 15-year-olds on Thursdays. And I've got 17-year-olds on Saturdays. Okay, so we got ourselves ordered pairs. We got ourselves a mapping diagram. Then asks us for the domain and range. Okay, well, domain and range, again, don't always have to be numbers. They are what things are included for your X's and your Y's. Well, for our X's, we have 15, 16, and 17. Just the parts and pieces of that mapping diagram. For our range, we had a Tuesday, Thursday, and a Saturday. Those are your Y's, and they're coming from this part of the mapping diagram. And part C is a relationship of function. We've got a couple ways to tell. We can look at our ordered pairs and see if we have the same X more than once. We can look at our mapping diagram and see if the same X points at more than one thing. Either way, I'm hoping you'll notice that, yes, we do have that situation. We've got the 15-year-old mapped onto 2 different dates. That's a problem for functions. Just because you're 15, it won't tell you what day to practice on. You have to know more information than that. So this is a relation, not a function. More than one arrow pointing. And I want to confirm this with a VLT, a vertical line test. So to do that, we need to make ourselves a graph. We usually graph numbers, but we don't have to graph numbers. We can graph days. Tuesday, Thursday, Friday. Oh, not Friday. Saturday. When we go to graph this, we also need to think about which is our X's and which is our Y's. And I purposely did that. I just wanted to say the fact that we can put letters down on our axes. They don't have to be numbers. But if you go back to what we started with, we said our X's were going to be our ages, right? So this really should be 15, 16, 17. Okay, and our day of the week is our Y's. So it should be Tuesday, Thursday, and Saturday. Now, these in order, sort of point of view, it doesn't really make a difference because they're words. What order you put them in. Each ordered pair is going to be a dot. So we had 15-year-olds on Tuesday, we had 16-year-olds on Tuesday, we had 15-year-olds on Thursday, and we had 17 on Saturday. So how can I confirm this is a function, not a function with a vertical line test? If I draw my vertical line right down there, what problem are we going to have? This dot and this dot twice. Okay, so we've got the mapping diagrams, we've got function or relation, we've got our vertical line test. Last idea. I want to know which of these are relations. Which of these are functions. I'm giving you equations this time. The trick is, do you recognize any of these equations? Now this course is definitely going to depend on some previous knowledge. You really kind of need to know a lot of stuff from grade 9 and 10 to be able to do most of the stuff in this course. It's really going to build. I'm hoping that you recognize the first equation as mx plus b, or in other words, a line. Well, what's true about lines? They go this way, or they go this way. Are those functions? Sure they are. Okay, every single line is a function except for one. The only one that's not would be a vertical line. And they have weird equations, like x equals 3. Okay. So if you come across a line, unless it's vertical, you should know automatically, oh, that's a function. And look at the second one. X squared plus y squared is 25. Again, I'm hoping you recognize this one as something we've seen before in grade 10. We saw it in this form. X squared plus y squared is r squared. That's a circle. Well, is a circle a function? Cross once, twice, it's never a function. It can't be a function. And the third one, I really hope you recognize that one because it's kind of basics for half the math we're going to do. There's a quadratic. In particular, this one is something in vertex form. And we graphed that yesterday. Okay, well, let's think about a quadratic. Is a quadratic a function? For sure it is. No matter where I draw that line, I only pass through the graph once. So all quadratics are functions. Doesn't matter what format it's in, vertex, factored, standard, a quadratic is always a function. Okay. Really the big trick here is you should recognize lines, you should recognize quadratics. The weird one, sort of the circle one, one of the big hints for a circle, how you know something is not a function. If you ever come across a y squared, write this down, a little star here, an exponent on y always means relation. Okay, you can have exponents on the x, totally fine. That's what quadratics are. But as soon as you see an exponent on your y, you know you have a relation and not a function. Okay, our homework, it's from our textbook. We were working on a little handout for this at the beginning of the course before we give textbooks out. Some questions to try. When you're doing question 4, in particular 4a, just pick one of the relationships. It's kind of like the soccer practice question. It gives you it gives you a table, a bunch of information. Just pick one. Okay, just get some little practice on that. And that's the end of our first lesson.